From previous session, we learned about web development using Golang and also we implemented RESTful APIs. As part of this session, we'll learn about how to write unit test cases using Golang and how to see the code coverage as part of testing. Let's talk about testing in Golang today. So overview of testing in Go. Testing is an important part of the software development process and Go provides several tools and libraries to help developers write and run tests. In Go, tests are defined as functions with names starting with test and are typically located in files with the name ending in underscore test.go. To run tests, you can use the go space test command. Go provides a built-in testing package called testing that provides a set of functions and types for writing tests. For example, you can use the t.Error and t.Fail functions to indicate test failure, and the t.Run function can run subtests. Additionally, Go supports table-driven tests, which allow you to write a single test that can run multiple test cases with different inputs and expected outputs. Go also provides a library called GoTest that generates tests for your source code. This can be useful for quickly creating tests for your code without having to manually write them. Unit tests are tests that focus on testing individual units of code, such as functions, methods, or structs. Writing unit tests in Go is easy and it helps ensure that your code works as expected and is free of bugs. In summary, Go provides a flexible and comprehensive testing ecosystem that makes it easy for developers to write and run tests for their code. Writing unit tests. Unit tests are tests that focus on testing individual units of code, such as functions, methods, and structs. Writing unit tests in Go is easy, that we discussed already, and it helps ensure that your code works as expected and is free of bugs. In Go, unit tests are written using the built-in testing package. Here are the basic steps for writing unit tests in Go. Create a new file with underscore test.go suffix in the same package as the code you want to test. So we'll go through the example, we'll get more details. Let us talk about next step. So write a test function for each function you want to test. The function name must start with the word test and take a pointer to testing.t as its only argument. Within the test function, call the function you want to test with the simple inputs and check the output against the expected values. So use the t.Error function to report any failures. So here if you see we are importing the testing package on the test add is the function that we are writing test for that, and add function we are calling by passing 1 and 2. The result, whatever result we are receiving here, result will be coming here, and expected is like 1 plus 2 is 3 expected. If result and is not equal to expected, then we are going to print the error message or the test case will be failed. If both are same, the test case will be passed. Let us see about like how this works for us. So in this case, if you see that I have written one simple function add a comma b of type integer, and it will return integer value of the sum of these two values. So the test cases looks like this. Result. So if you see carefully here, we are importing the testing package and add test. As we discussed, like test will be added prior to the function whatever we are going to write the test. So add is a function we are writing test in front of that, and we are passing the testing.t pointer, that is the argument it will take. A result equal to add 1 comma 2, expected is 3. So if these two are result is not equal to expected, then we are trying to use the testing package function error f. We are trying to print that error and the failure message. Similarly, I wrote one more function, one more file for division. So division actually it will take 1 and 2 values. I mean a and b of type integer, and it will return integer and its error. So in case b equal to 0, then we are returning 0, and because we are not able to, it will be infinite, right? Any number divided by 0 is. So otherwise we are trying to return the division value followed by the nil value. Right. So let us see like how we can, as we discussed, like we can use go test is the command to test the test cases of this file. So all good now. All test cases are passing. Everything is good. Right. How we come to know that all test cases are passed? We can see and we can run also. If you want, you can run individual test cases like this by using the tools. We can run like this. So you can print all the pass failure cases and all. Anyway. So let us see like other part of this thing like test coverage and all. So in Go you can use the go test command with various flags to get information about the test coverage, which measures how much of your code is covered by the test. Here are some commonly used coverage related flags for Go test. Dash cover. This flag enables coverage analysis for the test run and outputs coverage percentage for each package. Hyphen coverage profile, cover profile equal to you can give any output file. This flag outputs the coverage data to a file named coverage.out. And coverage mode equal to atomic. So this flag sets the coverage mode to atomic, which ensures that concurrent tests are properly accounted for in the coverage analysis. Example, we'll see like go test hyphen cover file coverage.out and coverage.mode is atomic, and you can give the path, and you can map using the tool to open in HTML format. This we'll see with an example now. So I just let us see the command as we discussed. Go test cover hyphen coverage file equal to coverage out and coverage mode is atomic. Let us run this command here and see what happens. Oops. Okay. So this is what actually we are doing. Go test hyphen cover and hyphen coverage profile equal to coverage.out and the coverage mode is atomic and I'm just passing the current path. So what it is doing is it is executing all the test cases and it is trying to create one file coverage.out file. This you can't understand anything now because this is in the format of the tool which whatever we used actually test tool which is generated with the line numbers and the which line is covered, all those kind of information. So to make it more readable, what we'll do is we'll try to map this into using the go tool. We can convert into HTML format. If you see this, it will come here like this. So high coverage for the file, if you see right add.go, it is covered actually. It is covered and low coverage also you can see that function is just called, and we can check for other file also. In this case, it is covered entire code basically. So that's why you can see that, right? So there is no red color here. That's why there is no coverage thing. We can see that. Let us test like no coverage thing also here. Let me delete one test case, this test case, right? And now let us run the same command to generate a new thing. And now if you see right for the second file, you can see that this particular line is not covered, no coverage. So because I deleted the test case which actually need to be executed here, right? So yeah, now if again run the same commands, so if you see this actually the second file, it will be covered. It is actually executed all the, I mean it covered the 100% of the two files of the test cases, unit test cases. Coming back to the this we already discussed. So best practices for testing Go code. Write tests for all important functionality. Make sure to test all the important parts of our code to ensure it works as expected and to catch any potential bugs early. Test all the edge cases. Test your code for edge cases to make sure it works correctly under all conditions. Keep tests fast and independent. Tests should be fast and not rely on external resources or other tests. This makes it easy to run tests and debug problems. Use table-driven tests. Table-driven tests are powerful way to write tests in Go that can run multiple test cases with the different inputs and expected outputs. Use the t.Run for subtests. The t.Run function allows you to run subtests within single test function. This makes it easy to organize and structure your tests. Test for errors. Make sure to test your code for errors and how it handles them. Document your test. Write clear and concise test function names and comments to document what each test is checking. Test coverage. Use code coverage tools to track the amount of code covered by the test and make sure all important parts of the code are tested. So this anyway code coverage thing we already discussed, and we have written all the test cases and test coverages for the sample codes.